What if it's too hard?
I'm gonna push through.
What if it's too rough?
I'm gonna push through.
What if it's too tough?
I'm gonna push through.
What if you're just too young?
That's not true.
What if you're not good enough?
That's not true.
Why? Because
I can do everything I put my mind to.
I believe in you.
Chin up,
Believe in yourself.
head high.
Tell me why.
We push through anything we put our mind to.
Okay, students, we are going to investigate the force push or pull. We see in the diagram a female pushing a little boy on a swing. We see another female pulling another female up. We also see a male pushing a door and another male throwing a box. And we know that throwing a box is a pushing force because a pushing force moves object away from you, right? So lastly, we also see a female pulling a dog. So we are going to look on force, and we're going to look on this test paper that was done on forces. So we know that a force is a push or pull on an object. All right. So here we have a test paper that was done on force. So we want to see how well we have learned about force or forces. All the questions on this paper are all PEP questions. Therefore, we want to see how best we can solve these questions on forces. And we already did a teaching and learning video on force, so none of us are blank slates on this topic, right? So, curious Tim's investigation. So, Tim has a curious mind, all right? And he wants to investigate forces on this pullback toy truck. All right. So what is curious? What does the word curious means? Curious simple means that a person is eager to know or learn. So Tim is eager to know or learn about this pullback toy truck. All right. So we see Tim was watching Teacher Alert, one of his favorite television shows, when he saw a report on a pullback toy truck. The truck would move forward when you pull it backwards. The toy truck had a pullback motor that provided the pushing force to move the truck forward. Okay? And we see Tim sitting in his couch watching Teacher Alert there. See? And the pullback motor can push the truck 3 meters. However, we are making new motors that will allow the toy trucks to move further distance. So you can see a cloud diagram there to show what the individual is saying about the pullback motor that we just read. So in that cloud right here, the pullback motor can push the truck 3 meters. However, we are making new motors that will allow the toy trucks to move further distance. So this pullback motor can only push the truck 3 meters. All right. So they are making new motors now that can move the toy truck a further distance. In other words, they are making this motor to move the toy truck further than 3 meters. That's what it's basically saying. All right. Now, after watching the show, Tim asks the following question. Will the new pullback motor produce a greater pushing force? And is that why the toy trucks can move a further distance? So this question is in Tim's mind. So Tim is very curious about this new pullback motor. Now, planning a fear test. So Tim wants to plan a fear test, all right? And we want to know what is a fear test. Now, a fair test is an investigation where one variable, which is the independent variable, is changed and all other conditions, which is the control variables, are kept the same. What is measured or observed is referred to as the dependent variable. Let us go into this. So here is an example of planning a fair test. So farmer Bob has two fertilizer. So we see fertilizer A there in the diagram and fertilizer B. Alright. We see fertilizer A, fertilizer B. Alright. And he is wondering which one will help his flowers grow the quickest. Alright. So farmer Bob, I should say, hypothesis is that the plant he treats with fertilizer B will grow taller and faster because B is more expensive. But we see a big word there, hypothesis. And we want to know what is the meaning of hypothesis. Alright, hypothesis is described as an educated guess. Alright, hypothesis is described as an educated guess. For example, we want to investigate whether a metal spoon will sink and a plastic spoon will float. Alright, so we make an educated guess to say that the metal spoon has more mass, so therefore the metal spoon will sink and the plastic spoon will float. So that's actually an educated guess. I am hypothesizing, alright, that the metal spoon will sink and the plastic spoon will float. So that's exactly what hypothesis mean. So let me go again. Hypothesis is described as an educated guess. The educated guess includes an explanation of why the guess may be correct. All right. The educated guess includes an explanation of why the guess may be correct. So that's what the word hypothesis means. All right. Now, the farmer compares two flower patches, all right, and we see two flower patches here. 1, 2. See the two flower patches right here where the cursor is, all right. So the farmer compared two flower patches. The patch treated with fertilizer A will be his control variable, which is this one right here, all right, because this is normal, or this is his normal fertilizer and it kept the same. All right, it is his normal fertilizer and it is kept the same. The patches that gets fertilizer B is the dependent variable because the variable will change, and we see B right here. So the patches that gets fertilizer B, which is this patch of flowers, is the dependent variable because the variable will change. All right, so this is what Farmer Brown wants to know. All right, does the type of fertilizer affect flower height? Does the type of fertilizer affect flower height? And this is actually a cause and effect question, as you can see right here. All right, this is because Farmer Bob hypothesis is that the type of fertilizer will actually cause a change in the flower height in 1 week. All right, let me say that again. This is because Farmer Bob hypothesis is that the type of fertilizer will actually cause a change in the flower height in 1 week. So we want to go to the next slide. So both his flower patches, which is the control variable on the left and the dependent variable on the right, must be treated the same way. All right, and we see two patches of flower here. We see one on the right, one on the left. All right, so both his flower patches, which is the control variable on the left and the dependent variable on the right, must be treated the same. We are dealing with a fair test, students. Therefore, they must get the same amount of water, the same flower seeds and also the same amount of sunlight. Those things that are kept the same are called constant. So anything that stays the same is called constant, and anything that ends up changing are called variables. So students, keep in mind that anything that stays the same is called constant, and anything that ends up changing are called variables. All right. Now, in order to answer his question, Tim wanted to plan a fair test. He wanted to find out how the size of different pushing forces would affect the distance an object moves. Tim planned to put 3 blocks on a toy truck, push the toy truck using different size forces such as strong force, medium force, and weak force. He planned to measure the distance the toy truck would move after each push. Now the diagram showing the setup of Tim's investigation, and we see Tim there with his toy truck with 3 blocks on it and a starting point marking S. Alright? Now Tim wrote the following steps to use when carrying out his fear test. One step is incorrect. So students, you are going to circle the step that should be rewritten so that his investigation represents a fear test. And let us go through the steps. So step 1, mark a point on the ground and call this point S. Step 2, push a toy truck from S using a strong force and measure how far it moves from point S. Step 3, push the same toy truck from S using a medium force and measure how far it moves from point S. Step 4, push a different toy truck from S using a weak force and measure how far it moves from point S. So, based on what you have garnered from the explanation of fear test, which one of these steps would be incorrect? And if you say step 4, you are indeed correct. Because if you notice step 4, Tim uses a different toy truck. And remember, when carrying out a fear test, everything must be treated the same. So in step 2 and step 3, he uses the same toy truck, but in step 4 he uses a different toy truck. So therefore this don't make this test fair. All right. So another example is like just like Usain Bolt. To truly test if Usain Bolt is faster than his peers, they all have to start at the same time. So they all have to wait to hear the gun fire. If one run off before the shooting of the gun, he will be eliminated from the race, because if he continues, that would not be a fair test, because a fair test must be treated the same. All right. Now for the incorrect step you identify in question 1, rewrite the step so that Tim's investigation will represent a fair test. All right, so you are going to do that. Students, this will be posted on Google Classroom. You go there and complete this activity. All right. Now Tim is concerned about the accuracy of the measurements he would gathered at the end of his investigation. So what should Tim do, if he wants to improve the accuracy of the results he will gather at the end of the fair test? So you are now going to circle the correct answer. All right. So A, measure more than once the distance the toy truck will move when pushed with the same size force. B, use a centimeter ruler to measure the distance the toy truck will move. C, count down each time before pushing the toy truck with a different size force. And D, push the toy truck on a smooth surface. So you are going to circle that answer. Remember, it's going to be posted on Google Classroom to be completed. All right. Now you have a diagram here. Now part 2, gathering the results, and you see 3 results there. So the join above, not below, show the results of Tim's fair test. Use them to complete the information in the boxes to the right of each join. You need to help Tim gather his results by measuring and recording the length of the arrow in centimeter using the ruler provided. This is the join distance, as you see in the diagram there. Calculate the actual distance moved by the toy truck, and note the actual distance moved is 100 times the drawing distance. So you're going to measure, what this is basically saying, you're going to measure the arrow here with your centimeter ruler, and the answer you get, you're going to put it beside the drawing distance right here. So the drawing distance in centimeter, all right? You're going to put the answer right here that you have garnered from the measurement, from the length of the arrow here, rather, all right? So the actual distance now, you're going to take the drawing distance and multiply the actual distance by 100, all right? So remember now, it says here the actual distance moved is 100 times the drawing force. So you're going to multiply the drawing force by 100 to get the actual distance, all right? You're going to multiply the drawing distance by 100 to get the actual distance, because that's what it says here, all right? In the note it says the actual distance moved is 100 times the drawing distance. So after you get the drawing distance by measuring the arrow, you are going to multiply the drawing distance by 100 to get the actual distance, okay? So in the diagram here showing the distance traveled by the toy truck when pushed with different size forces, all right? So the table shown above was created by Tim. Complete the table using the information gathered from the drawings in question 4. Alright, so the table must display the following information: mass of blocks on the toy truck in each result, actual distance traveled by the toy truck in each result, row and column labels, and note the mass of each block was 50 grams. Alright, and they gave us an example in the weak force, and they show the gram, which is 150 grams. All right, so we see result 1 strong, this would be result 2, which will be medium, and result 3, which is weak. All right, and as I said, they gave us an example of the gram, which is 150 grams. Therefore all of them must be 150 grams. So the strong force should be 150 grams, the medium force should be 150 grams. If I take you back to the toy truck, you see 3 blocks here. All right, so each block is 50 grams. All right, each block is 50 grams, so it's 3 blocks, so therefore 50 plus 50 plus 50 give you 150. all right, so let us go back. So all of them should be 150 grams because it's 3 blocks. So the strong force should be 150 grams, the medium force should be 150 grams, and the actual distance, you already worked that out here. All right, so the actual distance for result 1, actual distance for result 2, actual distance for result 3. So you're going to put it here. Actual distance for result 1 here, which is the strong force. Actual distance for result 2, you're going to put it right here. Actual distance for result 3, you're going to put it right here. So the same thing you're writing back from this. All right, good. Now part 3, below is the question Tim asks. So read Tim questions before continuing to question 6. So Tim questions: will the new pullback motor produce a greater pushing force, and is that why the toy trucks can move a further distance? Do the result of the investigation answer the question Tim asks? So you're going to complete that. All right, so use the result observed in the table in question 5 to support your answer. So you are going to do that, and you're going to go to Google Classroom, as I said before, and complete this activity. All right, so hope you have learned something. God bless you and stay safe. Peace.